We said with the functions of the database management system is to store data, retrieve, update data, be able to create databases. With the database, it not only allows you to define or create a database. After you design the database, you create the database. So you use a data model, you design, and then based on the design, you build the database. So with the database comes also, with each data item, certain information. The name of the data item, the type of values you can store in that, an integer, a number, a picture, audio file, video file, whatever it is. Right? And maybe some constraint. We said, for example, price could be a data item we store. The value, the type of the data is a number with a decimal point, and the range or the constraint or the condition in this data item is that the value should be greater than 0. Right? All this information that we said, the name of the data, the type of the value that it can store, the range, the condition are stored in what is called the catalog. So now it's not like a data file that you open the data file and you try to guess what this data is about. Each data item in your database, you can click on it and it will tell you what's the name of this data item actually, what's the type of value it will store, any constraints, possibly who created this data item, and what's the use for. So now you have got a catalog that gives you feedback on each data item. It provides you with transaction support, and you understand transaction support when you log into your student online information system and you enroll in a subject. That's a transaction you're performing. That's what's called a transaction. It's an activity that access, update, manipulate data in your database. Right? With concurrency control, there's something that is interesting, but we don't cover in this subject. Many people access the same database. So once you've got a database and you've got large number of customers, at any given time, large number of people will access your database. Many of them may access the same data item, and many of them may want to update the same data item. Can you think of a situation like this? That happens all the time. Let's say in your bank, you've got a bank account, basically account number, your name, your address. Another thing that's attached to your bank account is your balance, how much money you've got there. Each time you do a transaction on this account, you're either depositing money or withdrawing money, or you're just checking your balance and your data. Does this make sense? At any given time, several people can deposit money into your account. Several people can deposit hopefully into your account. If you're not very that lucky, many people will be withdrawing money from your account because you're paying bills. Right? If you're lucky, everybody puts money into your account. In any case, the balance is updated. The balance may have to be updated simultaneously by several people wanting to update your balance. So let's say you have got a shop that sells things online, and many people are purchasing your products. So the balance that goes in, your balance keeps on going up because they keep on purchasing your products. So many people at the same time may pay, and this balance has to be updated. Right? So concurrency control allows multiple people accessing the same data item. Right? As if they were doing one after the other. Because imagine if you've got 5,000 people on your website and 300 of them are purchasing right now a product or several products. So they should not wait in a queue like the queues in your shop, right? It should be all going through very quickly. So if people wait for a very long time to access a data item or update a data item, they may just give up. So the concurrency controls allows multiple users to access a data item and possibly update it as if it is done one after the other without interfering with each other. So at the end, you've got the correct value stored in your balance. Recovery services is another facility with the database management systems that allows you to recover, and that's what I said, recovery services allows you to recover from the problems that may happen in your database. Your database crash, or somebody may crash it, hardware failures may happen, and your database disappears. And you just lose some of the part of the database. So the recovery services allows you to recover your database, the data and all the transactions that happen into the database before it crashed. Is the recovery control facilities is intelligent, so that, for example, somebody wants to withdraw, you have got $100 in your account, somebody wants to withdraw $200 from your account, so this cannot happen. But at the same time, somebody is putting $500 in your account, right? Is it intelligent enough to understand? No, it doesn't work that way. It's not intelligent to understand that the balance should go in before this withdrawal happens. But if, let's say, five deposits happening at the same time, they don't overwrite each other. So it allows all of them to go through. This actually, the algorithm is done through a graph. And if you're interested, maybe next year you take our advanced database course and we'll tell you. And you'd be surprised, that's so simple. Yeah.
It doesn't make multiple attempts?
No, unless you build it into your application. Yeah. Okay, the other thing is authorization services. And authorization services is your access to the database through login name and password. Remember that now you've got total control on each data item in your database. So, as you saw in a 3-layer architecture, different people need to know different data items from your database. All right? So you can block people in accessing all the database. You can just say, with the students, if you're a student in this university, you can only see your own data. All the student data is stored in the database, but you only see yours. You can go further with this authorization and block people by giving them access or take access from them to read or write. For example, we can give you read access to your information that we have. And some of this information is, for example, your grade. If you studied before in this university and you passed or failed or whatever grade you've got for your, as a result for your subjects in the past semesters, it's available to you. You can see that grade, but you cannot update. So you can say, this person can see it, but cannot update it. Or you can say, this person, a student, can see their own details and also are able to update their telephone number or the address, or update their enrollment by adding new subjects to their enrollment for this semester, or removing some of the subjects that they don't want to study, continue studying. So the authorizations can block everything or give access to everything to the users based on the user's need. So you can say, for example, from the student, for an academic staff, the academic staff should be able to just see the name of the person and the subjects they're enrolled in, not their address. You can block us from that. Right? The next one is support for data communications. So this is happening all the time with the new services coming in. So you should be able to access the database from any locations. And these days with many different devices, from the web, from your mobile phone, from different devices. And with integrity services, and we'll go more into the details in weeks to come, once you set what the name of the data item is, what's the value or what's the type of value that can be stored in it, then I cannot store anything else. Once you said the name is price, the name of the data item, and the data that goes in it is a number with a decimal point, I cannot put anything else. I cannot just even put a number that doesn't have a decimal point. So the integrity control is to check that the right value, that the correct type of value is stored in the, and actually there's more into it, we'll talk about it. And then the other services that promote data independence, we talked about the 3-layer architectures. The utility services that comes with the database, that just allows you to give access to websites, to access your database, mobile services, etc. Going back to the system catalog, with the system catalog is the catalog of the data items that's in your database and descriptions of those data items, the type of value you can store, and any other constraint. Something that you may be familiar with these days, and you hear a lot about it, is called metadata. Metadata is extra data that describes another data item. So it's a data about data. Does this make sense? Hopefully it makes sense. For example, system catalog stores lots of metadata about each data item. So the data item price, for example, as a data item, has a metadata that is describing the type, the type of value that can be stored in it. Who can access this data item? The authorizations, informations, etc. So metadata is additional data that now connects to your data item and gives you more information, if you like, about that data item. Very useful. All right, with the components of the database management system, we just look at it. You saw two parts of the database management system. One was the data definition language. Another component is the database management, data manipulation language. So here is basically on the top we have got different applications and users accessing the database management system software. The data management system software is in this box. Data manipulation language, data definition language. You will learn about different parts as we go through the course. So you don't have to memorize anything here. So all you need to know so far is that there are two components. What's the data manipulation language for manipulating the data in the database, and data definition language for defining the database. And each of these components has got many subcomponents in it. For example, data manager that you saw probably in the last one, in here handles lots of issues in the database management system software. It's just an overview. You don't have to be concerned about that. What I want to talk about is here, and usually I just cut this bit out of my lectures. This year I decided to just leave it there because it's just part of the chapter 2, just a few pages, is on multi-users database management systems architectures. And here we're talking about not the 3-layer ANSI Spark architectures. Here we're talking about how we put hardware together to give access to the users to access the database. We can do it in different ways. For example, in the file server approach, where you have got the database management system software is stored on one machine. Sorry, let's just show you the picture. I think it's better. Where the database is stored on one machine, and the database management system software is stored on each of these workstations that access the server. So with this architecture, you've got multiple, basically copies of the database management system stored in different workstations. If your server fails, you've got no access to the data because you have got no access to the database. So each one of them have got some advantages, some disadvantages. This is just for you to read. It doesn't cover enough materials. If you're interested to know more about hardware, software, and the communications, you take our client-server architectures, and that goes through all this. It's just for you to know where the database management system can be installed. So in the 2-tier client-server architectures, you've got the database management system sitting on the server. The database is also sitting on the same server. So your clients just have got a client version of the database management system, not the whole database management system. And they just access the database management system on the server and the database. So the advantages here is you just basically have one place where the database management system software is, and you do all your updates, etc. here. So this is something that you may want to read. It's just one page in your book, as I said, and each one of them have got some benefits. These days we use a client server where you have got all the details. The database management system is stored in your server. Your database could be in another server or on the same server, and then you use your workstations, your mobile phones, or whatever, to access the database. And so all the updates, all the hardware, software updates happens on the server side, and we really don't care about what's happening with the client side. It's just a client application that connects to the server and access everything.